unveiling emotions in text, sentimental analysis with NLTK. Introduction. In the various landscape of language, where every word carries the weight of human expression, lies a fascinating journey into the realm of sentimental analysis. As we navigate through the intricacy of language, our ability to decipher the emotion, opinions, and attitude hidden within the text becomes a key to unlock a wealth of insight. As the art of this linguistic odysseys in the language toolkit, a powerful and versatile Python library that serves as a guide into the intricate world of sentiment. Sentiment analysis often refers to as the art of understanding sentiments in text as transcribed into roots in natural language processing to become an indestructible tool in various domains. For devising customer sentiments in product reviews, for gauging public opinion on social media, the application are various and profound. NLTK, with its arsenal of linguistic resources and sophisticated algorithm, empowers us to unravel the layer of sentiment concealed within the hidden words. Foundation of sentimental analysis, text processing, cleaning and preparing text for analysis, removing noise, stop words, and irrelevant information. Feature extraction, transferring raw text into numerical features. Techniques such as bag of words, TF-IDF, and word embedding. Sentimental labels, defining sentimental labels positive, negative, neutral. Creating annotated database set for training and testing. Supervised learning, introduction to machine learning, model of sentimental analysis, training classifiers using labeled data. Unsupervised learning, exploring unsupervised approaches including lexon space method, understanding sentimental lexons and dictionaries. NLTK powered sentiment analysis. NLTK, a robust Python library for natural learning processing, stands as the realm of sentimental analysis. Key features, text processing capabilities. NLTK provides a comprehensive set of functions for cleaning and processing textual data, ensuring that noise is minimized. Lecture resources, with access to the vast array of lectures resources, NLTK enhances sentimental analysis by allowing models to train on rich linguistic data sets, improving accuracy and relevance. Machine learning integration. It's compatible with various classifiers, empowers users to train models on labeled data set, making the analysis updated and accurate.
Various methodologies used for sentiment analysis. The first one is rule based sentiment analysis, which is to understand how the rule based methodologies in NLTK involve defining sets of rules or patterns. And the second one is machine learning based sentiment analysis, which explore the NLTK's integration with machine learning algorithm. Then we have hybrid approaches, which is the combination of rule based and machine learning approaches. Then we have accept based sentiment analysis, in which it goes beyond overall sentiment and analysis sentiments associated with specific aspects or features. Then we have deep learning approaches, which explore how NLTK can be integrated with deep learning techniques such as recurrent neural network or transformer models. Next, we have implemented the code using the machine learning based methodology analysis, specifically employing the naive Bayes classifier. So, the key components and steps are data loading, in which the positive and negative movie reviews from the NLTK movie reviews corps are loaded for training the sentiment classifier. Next, we have feature extraction. The create word feature function is defined to extract features from the reviews. It selects useful words, removes stop words, and includes both unigram and bigram features. With third one, we have data preparation. The feature are set to create for both positive and negative reviews, and the data is split into training and testing sets. Then we have the training, the classifier, in which the naive Bayes classifier from NLTK is trained on the feature sets using the training data.
Now let's see the code. First step is to import all the necessary libraries we need to use in the code. First is importing NLTK, which means Natural Language Toolkit, which is used to get the resources from WordNet. Next we have NLTK.corpus, and we are importing the movie reviews, which have 2000 movie reviews categorized into positive and negative sentiments. Next we are importing the naive-based classifier, which will classify the movie reviews as positive or negative based on the words present in the reviews. Next we are importing the accuracy, which will compare the predicted labels with the actual labels in the test datasets. Then we are importing the tokenizer, which will split the text into a list of words. Then we are importing the stop words, which means the, and is are being removed from the text during the pre-processing. Then we are importing the bigram, which means we will take only 2 words in a sentence at a time, and then we will pre-process it. After that, we will download the kits, like for movie reviews, for stop words, for punct, everything. We will download the data sets. After that, we'll make a list called as positive reviews. Then we'll start a for loop, which will iterate through the sentence, and will take the words which is a positive review and will append to the positive review list. It will continue to the negative reviews too. Find a function called create word features of words. In that, what will happen is there will be a variable called useful words, a list which will contain all the words in English without any stop words. Then we'll declare a dictionary called mydic, which will have each of the useful words list becomes a key in the dictionary, and the value for each key is set to true. Then we'll include the bigram as feature, which will create a list of bigrams from the useful words. From that, we will iterate through all the bigram words, and with the value set which is true, then we will return the dictionary. After that, we'll create features as positive feature and negative feature. Here what will happen is the line uses a list combination to create a list of features set for positive movie reviews. For each positive review in the positive reviews list, the create word features function is applied. The same will be applied to negative features too. After that, we are splitting the dataset into training and testing datasets. The split ratio is 0.8, which means that 80% indicating the training dataset, and the remaining 20% will be used for testing datasets. The positive split, the length of the positive will be splitted, and it takes only 80% of the length of the positive features, and then it will be converted to an integer. Similarly, it will be applicable for negative split too. The training set will be combining the first positive split elements from the positive features and the first negative split elements from the negative features. The test data, the line creates a testing set by combining the remaining elements from the positive features and the negative features. We will train the naive-based classifier. Here what is happening here is it will create an instance of the naive-based classifier class and trains using the provided training set. The classifier learns the association between the features and their corresponding labels, positive or negative, based on the training sets. After this, we are evaluating the classifier on the test data. This is here the NLTK accuracy function is used to calculate the accuracy of the classifier on the test data. Next, we are printing the F accuracy. This line that prints the accuracy in a formatted string. The F string is used for string formatting, which will be round off into 2 decimal values. After that, we are performing the sentiment analysis on a new text. Here what is happening is, here we are creating a function called def sentiment analysis of text. Here what will happen is, there is a word equal to word.tokenize of text, which will tokenize the process of breaking down the text into individual words or tokens. Here a feature is there which was defined earlier. It takes a list of words as input and creates a feature set using the same feature extraction. Now it will return the classifier. After that, we are giving an example usage, like I got bored while watching the movie, the plot was good and the acting was awesome, which means that it is a negative sentence. It will take the text to analyze, and the result will be, in the result we will call the function text to analyze in the sentiment analysis, and it will give the result. After executing the code, the output in the output we'll see it is downloading the package of NLTK. The stopwatch is downloading the print kit, everything they will download including the movie reviews datasets. After everything is ready, they will give accuracy of 78.25% by calculating the accuracy through the NLTK importing libraries. After that, the sentiment is negative, which means the sentence which we are given is a negative review. After that, we have given the collab link to the code.
Advanced technique for sentiment analysis. WADR, Valence Aware Dictionary and Sentiment Reasoner. So WADR included in the NLTK library but can also be used independently. WADR is an effective handling sentiment in short, informal text with emotions and slang. Okay, and the next one is TextBlob. TextBlob builds on NLTK and provides a consistent API for common NLP tasks. It includes sentiment analysis and it is used as a pre-trained model to classify text and positive and negative or the neutral statements. And the next one is Transformers and BERT. So BERT, bidirectional encoder representations from transformers. So it is a transformers based model which have revolutionized natural language processing tasks including sentiment analysis. So GPT. So all of you are well aware about ChatGPT. So generative pre-trained transformer is known as GPT. So it's a system developed by OpenAI. Are powerful language models which is tuned for specific tasks like sentiment analysis. In particular, has shown a remarkable performance in understanding the generative human-like text. The application of sentimental analysis. Mostly it is used in business insights, social media monitoring, and financial decision making. So, in business analytics, sentiment analysis extract valuable insights from customer feedback and reviews, enabling business to enhance its products and marketing. Social media monitoring social media through sentiment analysis help to organizations track brands for mentioning or managing the customers which they requires on their basis. It's on the basis of real-time public sentiment. Financial decision making. In financial markets, sentiment analysis aids traders and investors in making informed decisions by gauging market sentiment from news, social media, and financial supports. So, in conclusion of our presentation, in the expansive realm of sentiment analysis, we have embarked on a captivating journey, exploring the intricacies of dis- deciphering emotions, opinion, and attitudes with textual data. From the foundational principles of the application of advanced techniques, our exploration has begun, guided by the powerful Natural Language Toolkit or NLTK, and extended into the realm of sophisticated language models and algorithms. In conclusion, sentiment analysis stands at the intersection of language, technology, and human expression, offering a lens through which we can understand the sentiments woven into the fabric of our digital conversion. As we navigate this ever evolving landscape, the tools and methodologies at our disposal continue to unlock the mysteries of sentiment, allowing us to glean valuable insights and make informed decisions in an increasingly data driven world.